Two complex numbers can only be equal if their real parts are equal and their imaginary parts are equal. So a plus bi being equal to c plus di must mean that a is equal to c and b is equal to d. So we want to find real numbers x and y in this situation here. So on the left here we just need to expand out. So what do we get? We're going to get 2x, take away xi, plus 2yi minus I squared y. That's all got to be equal to negative I. So the I squared, of course, is negative 1. So the real part of this is going to be 2x plus y. And then the imaginary part is going to be 2y minus x. Now, if it's going to be equal to negative I, that tells us that 2x plus y, the real part, has to be 0, and 2y minus x has to be equal to negative 1. And so we have simultaneous equations. So I've got 2x plus y equals 0, and I've got 4y minus 2x is negative 1. So if I add these, I get 5y equals negative 1. So y is going to be negative 1/5. And so we must have 2x is equal to 1/5. So x is going to be 1/10. Okay, I've got a similar sort of situation here. Let's expand out. What do we got? We've got x, take away xi, plus 2i, minus 2i squared is equal to 5 plus yi. So I squared is negative 1, so the real part is x plus 2. And then I've got plus I, 2 minus x, is equal to 5 plus yi. So x plus 2 is equal to 5, looking at the real parts, so that gives me x is 3. And therefore, substituting back in, this would be 2 take away 3 is negative 1, so y must be negative 1.